One unique part of the relative dating story is the story of unconformities. And unconformities are gaps in the rock record. So, talking about original horizontality and superposition, you have one layer coming right after another, stacks and stacks and stacks of sedimentary rocks. With unconformity, something has messed up that sequence. Either it's because there was a time when there was no deposition, or maybe there was deposition and those rocks got eroded away, and then more rocks were deposited on top of that. So there are different ways that unconformities can form. And an unconformity is that line. So on this image right here, this line I'm tracing where the rock hammer is represents the unconformity. So in the geology sketch over here, here's that line. So unconformity is a surface that represents that gap in time where there's no record. There are three kinds of unconformities. There is the angular unconformity, a nonconformity, and a disconformity. We'll go over all three of those. But essentially, an angular unconformity is like the one in the image, where you have beds that are no longer horizontal, right? They're at an angle. And then there's beds on top of those at a different angle. So something had to happen between the deposition of this sandstone and shale, tilted it, and then the sandstone was deposited on top of it. So there's that time between the deposition, the tilting, time, and then the next rock deposit on top of that. That's the angular unconformity. So let's look at the three kinds. So here's angular. And here is a really big angular unconformity. This horizontal line represents the unconformity surface. And then the slanted line here is representing the angle of these beds below the unconformity. So they were flat lying, some geological event, tectonic activity tilted them, and those white beds deposited on top. So during the time when all those beds were tilting, no deposition was happening, and then there was erosion, and then like basically sea level had to rise. See in time 3 here at the bottom, the water had to rise up so that those white beds could be deposited. So a lot of time, millions of years between the deposition of the layers, the tilting, sea level rising, and new beds forming. Angular unconformity. Here is, so Hutton, who we talked about before, this is a famous place in Scotland called Sycamore Point, and it's a kind of a mecca. A lot of geologists go there to see the difference between the tilted beds and the ones on top of it. 50 million years of time between the deposition of the two. Okay. Nonconformity is going to form between, turn this off, between either igneous and metamorphic rocks, igneous or metamorphic rocks, a crystalline rock, and then on top of that are going to be sediments. So we talked about how igneous and metamorphic rocks, intrusive ones, if it's igneous, form underground. So in this example, there's a granite. Here's a granite. And it cooled and crystallized underground, was uplifted to the surface, and so that granite was eroded flat. So granite was the bedrock at the surface of the earth, and then the sea rose up, and then there was deposition of these sandstones. So there's a lot of time between the cooling and crystallizing of that granite, the uplift and eroding flat, and then sea level rising. So that leaves behind what you see on the left here, a granite down below, and then this surface here is the unconformity, where later the sandstone was deposited right on top of that granite that was deep in the earth. Okay, that is a nonconformity. The last one is a disconformity, and disconformities are a little bit harder to recognize. Sometimes there can be features that we can see. So in here, in this example, we have time 1, the deposition of these units in a basin in water, say the ocean. And then later, those beds were lifted up to the surface. that surface that they're showing here is a dotted line, then there was erosion. And then later, the sea level rose again, and now we have the water here and deposition of more sediments. So in the image, this is the erosional surface. It has some, it's not just a planar feature that goes, it eroded down into this channel here. Paleosoil means that there was an ancient soil horizon formed there. And all these sediments above it are much, much younger. They were deposited on top of what was basically rock.